Okay, here we are, part 6 in how to construct a diagram that generates all 360 degrees using base 12 geometry. Okay, so I'm looking again at the first initial ring of the diagram. I just wanted to show you all of these numbers here. Basically the conversions between base 10 and base 12. You can see, 24, 48, 72, 96 counting in base 10 in 12s, and then the corresponding base 12 version that looks like it's in 10s. So that's what that looks like. Here's the first ring, and then I've gone through the first 1, 2, 3, 4, 5 rings. And the one thing I didn't mention or didn't talk about too much was the angle that's being formed inside of the small circles as the rings progress. So we started off with the first calculation of 119 in base 12 or 165 in base 10. So the next ring, we're using that same formula, n minus 2 times 180 in base 10 or 130 in base 12 divided by n, where n is the number of sides in the polygon. I got that formula actually up there. I don't know if you can see it, but basically I just wanted to go over here. I'll say it, the base 10 version, 172.5, then 175 degrees for the third ring, 176.25 for the fourth ring, 177 degrees. We're working our way to 180 would be a flat straight line, so we're never going to get there, but we're already at 177 or 129 in base 12. We're going to 130 in base 12, but remember there's still an A and a B in there. So that's what that looks like. Again, we went over all these circles in the last video, so I'm going to switch the board up now, and we will go to the next board and just continue exploring what this diagram looks like as we progress from ring to ring to ring. Okay, so here's the next board in the series as we're going across the bottom. This is our x-axis again. So this is the 6th ring over here. And again, you can see now we're back to the 5-degree line, and then sections of 5, 2.5, and then 1 1.25. So this degree line here is going to be 1.3, and that's the 6th ring. So again, how I was saying, you count 7, 8, 9, 10, 11, 12. So if you go down to there's the 1.3, and now it's above that bottom circle. So again, you can see the relationship, how as the rings sort of double in distance from the center, the degree lines are related to each other. So we'll just go back there. We were talking about the angles inside of the small circle. So here on the 6th ring, the one before was 129 degrees is the inside angle. Now it's 129.5. Then 129.835. There we get a repeating decimal. Here it's 128.16 or 178.125. And then just continue along, 178.3 repeating for the base 10, or 128.4, 128.6, 128.7's repeating, and then 128.9 on the 12th ring of the circle, speaking in base 10. So I know I'm going back and forth, but I think you get it between base 10 and base 12. And again, you can see here's the 6th and then the 9th ring. Again, it's the 5-degree sections. Here we're at 1.8, which is going to, half of that is going to be 0.9, I think. Yeah, 6.8, I should say. And then there's, again, they just progress. So the next ring after that is 7, the 7th ring in the circle, and that's where it starts to get a little bit, well, not really starts to get a little bit messy, but these are all new degree angles that we hadn't generated before. So again, we're going to have our 7.5 degree line here that we can work with. We put our circle right on that line. Here we have our x-axis, and we're able to generate this circle here. Twinning the x-axis, we create those 2 points with our method of putting the compass and finding the point on the inner circle and the outer circle. So once you've got these two circles, we can find the middle point between them, which is going to be right here. That's our new degree line of 4.35186A. And then once we've got that degree line established, we can put our compass down on the inner large circle and then do that same twinning process, and then we can create those two circles. And then once we've got them, we can generate the new angle here and the new angle there. And again, it's just that process of finding the midpoints either between the degree lines or the circle points, and then just continuing until you've found all the different points and created your new degree lines for that particular ring in the diagram. But none of these degrees at this point are going to show up in our 360 degree, and that's kind of what I'm focusing on. But you can see how each ring can be completely generated. You can fill in all the blank spots, so you get all the degree lines of that section if you're wanting to go that, create those degree lines for whatever it is you're using this diagram for. At this point, it just feels like we're generating the diagram for its own sake. But of course, this is a tool that can be used to plot and find points and map out things. Let's leave it at that for now. So here, that's the 7th, the 8th ring. This is repeating from the 4th ring. Again, same process. You can see 8th, 9, 10, 11, 12. Here's the 3 degrees. Half of 3 is 1.6. Half of 1.6 is 0.9. There's the 0.9. Again, you're just using the compass. It's all about the compass and finding the midpoints and then creating your new degree line. So I think that's really it. What I want to do now is go to the last or the 15th ring in the section. Here we're going to the 12th. Here we're going to the 12th ring. So 13, 14, 15 is the last ring of this particular diagram, which again is halfway to 30, and the 30th ring is the actual final degree line. We want to get to a point where one of these big circles is actually just 1 degree. Right now we're kind of looking at these little circles as our measures of degree, but it really is the big one that we're looking for. So I think you can see how that works. In one way I'm going fast, but on the other hand, I just want to be introducing you to the concept. And if you really want to understand this, you're going to have to kind of play around with it yourself and make it your own. Explore the idea that we're doing it in base 12. Again, the dodecagon shape is kind of underneath all of this. The gap that we have to work with is being sort of spread out between all these circles. There's a gap in there of 0.06 root 2. It's all in units of square root of 2. That's a given. It's all the same bases that we started with. The same structure is there. So now I'm just going to go to the last ring, and we'll take a look at that and then just see how it works out from there. Actually, I was just getting ready to move this board, and then I noticed that the radius of the last ring was 32 root 2. So I thought I would mention that because we have been working in units of 3.2 root 2. That's the gap between each ring, or each ring is a consecutive section of 3.2 root 2. That was the radius of the very first ring of the diagram. So now we're at the 10th ring in base 12, and we're going to the 13th ring in base 12, which is the 15th ring in base 10, which is halfway to 30, which is okay. So I think you got all that. And again, just want to mention, that it's all working out or lining up, so to speak. And I think I'm just going to stop it there for this video. And then the next video, we'll go into the last, the sort of vertical board that has all the degree lines on it for the 15th degree. And that's where they actually all show up, the 1, the 2, the 3, 4 degrees, and so on. And then we just jump from there to the 30th ring. So, hope you enjoyed this little section of the diagram and just sort of seeing again how it all plays out. And that's pretty straightforward in the construction of the process once you understand all the logic and the steps that you take, drawing the first circle, then the second circle, the 2 rings, and then working off of that sort of structure to create all the different degree lines in each ring. So hope you can join me for the next video where we look, I think we're getting to the final video of this, how to draw a diagram that generates all 360 degrees. So yeah, hope you can join me for that. Thanks for watching.